Have you ever sat on a train and just looked around? You've got the CCTV cameras, the passenger info screens, the intercom. It all just kind of seems to work. But behind the scenes, getting all those different systems from all these different companies to actually talk to each other, well, that can be a massive, massive headache. Today, we're going to pull back the curtain and demystify the international standard that makes all that seamless magic actually happen. All right, so here's our game plan. We're going to start with the big problem, the challenge of getting all these onboard systems to play nice together. Then we'll get into the master blueprint, IEC 625801, which is basically the common language for everything. After that, we'll zoom in on a super important application, CCTV, to see it in action. We'll look at how it all gets wired up, and then we'll talk about the big payoff, why all this standardization is such a game changer.
So first up, the challenge. And really, you can think of it as an onboard Tower of Babel. Modern trains are just packed with incredible technology, but so often each system is speaking its own private, proprietary language. And that leads to chaos.
I mean, just picture this. You couple two train cars together. One was made by Company A, the other by Company B. All of a sudden, the security cameras in one car are completely invisible to the driver in the other. Passenger alerts only show up on half the screens. It's a total operational nightmare. And honestly, it's a huge safety risk. This is the exact problem that desperately needs a standard solution.
So that brings us to the million-dollar question, right? In this world with all this diverse tech from countless different vendors, how on earth do you create a universal translator? How do you get every single one of these systems to speak the same clear language? Well, the answer is IEC 62580-1. You can think of this standard as the master blueprint for communication. It doesn't actually build the house, but it gives everyone the architectural plan that makes sure every single room connects perfectly. Okay, so the official fancy term the standard uses is Onboard Multimedia and Telematic Subsystems, or OMTS for short. Now, the key word to focus on here is non-operational. The standard has nothing to do with the train's brakes or the engine. Nope. It's all about the crucial information and communication tech, the ICT, that serves the crew and passengers. And to keep everything neat and tidy, the standard does something really smart. It breaks all these OMTS systems down into 4 logical categories. You've got Category A for video surveillance, which we'll be focusing on. B is for crew services. C is for passenger stuff like info displays and Wi-Fi. And D is for maintenance data. It's a brilliant way to create structure out of pure chaos. Now, the absolute heart of this master blueprint is a concept called service-oriented architecture, or SOA. I know, it sounds super technical, but the idea is actually pretty simple. It separates the job an application does from the way it communicates. So, for example, the job of a CCTV monitor is to show video. With SOA, it doesn't need to know all the complicated network stuff about how the video gets to it. It just asks the network for the video streaming service, and the network figures out the rest. Let's make that even simpler. Think about a crazy busy restaurant kitchen. The chef is your application. Let's say it's that display monitor. The chef just shouts, "I need tomatoes." That's the service request. They don't know and they don't care if the kitchen staff had to run to the storeroom or get them delivered by a drone. They just get the tomatoes. That, in a nutshell, is SOA. Simple requests for complex services. Okay, so we've got the blueprint. Now, let's see how it's actually used to build something real, and something that is absolutely critical for security, the onboard CCTV system. And for this, we have to look at the second part of the standard, IEC-TS 62580-2. So if Part 1 is the general architecture plan, you can think of Part 2 as the specific, super detailed instruction manual for building a totally interoperable CCTV system that fits perfectly into that plan. According to the standard, any legit railway CCTV system has to perform these core functions. It's got to capture video, record it, let the right people retrieve and replay it, show it on monitors, and sometimes even analyze what it's seeing. The whole goal of the standard is to make sure a camera from one brand can have its video recorded and displayed by gear from a completely different brand. Okay, let's connect the dots here. How do these big, high-level ideas from the blueprint actually turn into a working physical system? Let's see how we go from blueprint to build. This slide really lays it out perfectly. Part 1 gives us the big idea, this service-oriented architecture. Then Part 2 comes along and gets really specific, saying, okay, for CCTV, we are going to make that happen using web services. Part 1 creates a bucket called CCTV, and Part 2 tells you exactly what mandatory services, like streaming or recording, have to go inside that bucket. And this diagram just brings it all to life, doesn't it? You see the cameras, the recorders, the monitors, all of which could be from different manufacturers, all talking to each other seamlessly over the train's network. Because they all speak that common language defined by the standard, you can just plug them in and they automatically discover each other and start using each other's services. That is the power of interoperability. And right here, this is where the real magic happens. The standard literally mandates that for a device to be compliant, it must offer these specific services. So, take a look at video recording. Any compliant recorder absolutely has to provide services for recording control and search. This is what guarantees that an operator on any monitor can search and pull up footage from any recorder on that train, no matter who made it. So, we've walked through the problem, the blueprint, and the real-world application. Let's talk about the payoff. Why go through all this trouble? Why does any of this really truly matter?
Well, the benefits are just huge. Train operators are no longer locked into one single vendor. They can mix and match the absolute best equipment for the job, knowing it's all going to work together. This gives you a massive boost in safety. A guard can instantly pull up footage from any camera on the entire train, not just the ones in their PAR. Maintenance gets way simpler, and maybe most important of all, the train is now future-proof, ready to bring on the next generation of tech without having to rip everything out and start over.
And this quote, straight from the standard itself, just nails it. The main benefit is to decouple applications from communication aspects. By separating the app from the complex network stuff, you guarantee that things will be compatible today and tomorrow. The technology underneath can change and evolve, but as long as the services stay the same, the systems will just keep on working together. At the end of the day, standards like IEC 62580 are the invisible foundation that our modern, intelligent, and safer railway systems are built on. They make that seamless integration that we all just expect possible, and they create a more efficient and secure journey for every single one of us. And that leaves us with a final thought to chew on. This whole service-oriented framework is built to grow. We've tackled CCTV interoperability. But what's next? Real-time passenger load counting? Automated maintenance alerts that ping engineers before something breaks? The structure is there, ready for the next big thing in rail tech. So what do you think it's going to be?